electron is the first subatomic particle to be discovered. Let us now see how this first subatomic particle, which is electron, was discovered. Electron was discovered by a scientist named J.J. Thomson in 1897 with the help of cathode ray discharge tube. This whole setup, this is known as the cathode ray discharge tube. With the help of this experiment, J.J. Thomson was able to discover electrons. Now let us see how this experiment was conducted. In this experiment, these are all made up of glass. We can just imagine to be in the form of a tube light. In this setup, he took two electrodes, cathode and anode. This anode, it was a perforated anode. Perforated anode means it will have series of holes in it. And at the back of this perforated anode, fluorescent screen was attached. This is the vacuum pump. The whole purpose of this vacuum pump is to suck out all the gas from this tube and also to ensure to make the pressure as low as possible. In this discharge tube, gas is embedded, and with the help of this vacuum pump, the gas is sucked out to maintain lowest pressure. The lowest pressure maintained in this tube was 10 to the power minus 3 mm of Hg. Mm of Hg is a unit for the measurement of pressure. In this setup, high voltage was applied, almost 1000 to 10,000 volt. On application of high voltage, what happened was some rays from cathode started moving towards the anode. However, this ray was termed to be invisible. So the question arises here is that how were they able to indicate or detect the presence of these rays? As we know that in the setup, fluorescent screen was placed. Fluorescence has a property of illuminating on the absorption of light or radiation from a different source. So here in this experiment, it was found that this fluorescent screen was illuminating continuously. That means it was glowing continuously. So it was found that some rays are passing from cathode to the anode, that is from the negative terminal to the positive terminal. And we all know that opposite charges attracts each other. Since from the negative terminal it was getting attracted to the positive terminal, it was concluded that this rays which is coming out from the cathode must have a negative charge. That is the sole reason why it is getting attracted to the positive terminal. So from this entire experiment, the first thing that was concluded was that the properties of cathode rays were found. The properties were that cathode rays have negative charge and they were termed as electrons, and they pass in a straight line, and also they possess kinetic energy. Kinetic energy is the energy due to motion. That means anything that moves will have kinetic energy. So this was the properties discovered through this experiment. Now J.J. Thomson, he also measured charge to mass ratio with the help of some experiment which we will not be going in very detail. So the charge to mass ratio was found to be 1.75 into 10 to the power 11 coulomb kg inverse. After finding out the charge to mass ratio, he also conducted this experiment by embedding different gases in the tube as well as changing the materials of the cathode and anode, also swiping the electrodes. But every time he did something new, he found out that the charge to mass ratio for every experiment was found to be 1.75 into 10 to the power 11. That means the charge to mass ratio did not change at any cost. So from this experiment, he concluded another thing was that these cathode rays to be fundamental particles because it did not depend on the nature of the gas embedded, neither it depend on the material of the cathode. So the second thing that was concluded here is that cathode rays are fundamental particles and it is same for every particle. Another scientist named Millikan in 1906 to 1914, what he did was he did an experiment on oil droplets. in order to ensure and in order to determine the charge present on the cathode rays, that means electron. From his experiment, he found out that the charge present on the electrons were 1.6 into 10 to the power minus 19 coulombs. The acceptable value in today's date is 1.602 into 10 to the power minus 19 coulomb. So from here till now, the charge to mass ratio was known, the charge of the electron was known. So with the help of these two values, the mass of the electron was easily calculated, which was 9.1 into 10 to the power minus 31 kg. So from this entire experiment, the charge to mass ratio was known, the charge was known, and even mass of the electron was known. So J.J. Thomson helped in the discovery of electron and also helped in finding out the charges, the masses. It is because of his experiment that the electron was discovered in 1897. After the discovery of electron, what happened was that this experiment became very famous, and every scientist during those days wanted to perform this experiment, either the same experiment or by changing some of the materials. Now the discovery of proton was also the outcome of J.J. Thomson's experiment. As said that many scientists were performing the same experiment either by changing the materials or the same experiment. So one scientist named as E. Goldstein, in the early 90s, he also wanted to perform the same experiment conducted by J.J. Thomson. But in his experiment, he made some changes which were, in case of J.J. Thomson's experiment, perforated anode was taken. But in E. Goldstein experiment, he took perforated cathode. That means cathode having series of holes, and a fluorescent screen was placed just at the back of cathode. And the voltage maintained in this case was also very high, as similar to that of J.J. Thomson. The pressure here was a little higher than J.J. Thomson's experiment, which was 10 to the power minus 1 mm of Hg. The sole reason for maintaining lowest pressure is that whenever any rays are coming out, they do not collide with each other. And the vacuum pump, it sucks out all the gas, ensuring that no air pressure is formed inside the tube. So upon applying high voltage, some rays were found to transfer from anode to the cathode. In the case of J.J. Thomson, the rays were invisible. But in the case of E. Goldstein experiment, some colorful rays were found to travel from the anode to the cathode, and they were striking the fluorescent screen, causing illumination. That means it was glowing continuously. So since the rays were traveling from the positive terminal to the negative terminal, the scientists concluded that these anode rays must have a positive charge, which is why it is getting attracted towards the negative terminal. So from this experiment, it was concluded that anode property includes it has a positive charge, it travels in a straight line, it also has kinetic energy. From J.J. Thomson experiment, it was also concluded that cathode rays are made of electrons. But anode rays are not made of electrons, they are made of gaseous ions. Now, similarly to J.J. Thomson's experiment, just as he also employed different gases and checked the charge to mass ratio, even E. Goldstein, he employed different gases. In order to check the charge to mass ratio, he also changed the material of the electrode and even swiped them, and on doing so, he found out that for every experiment he conducted, the charge to mass ratio came out to be different for every case. So, he could not conclude that anode rays are fundamental particles because they were different for every case. So, he wanted to take up a gas which could provide the highest charge to mass ratio. So, he kept on selecting gases and found out that the gas with the least mass, that is hydrogen, upon taking hydrogen gas, it was found that the charge to mass ratio came out to be the highest. So, he concluded that anode rays are not made of protons, but in case of hydrogen, upon taking hydrogen, we all know that hydrogen have one proton, So upon taking hydrogen, we can say that anode rays are made of proton. So from this experiment, the charge of the proton was calculated, the mass was also calculated. The charge was found to be similar to that of the charge of the electron. The only difference was in their sign. That means electron had a negative sign and proton had a positive sign. So this is how the first two subatomic particles were discovered by J.J. Thomson and E. Goldstein. If you Google it, you will find that protons were discovered by Rutherford, but the main person behind the scene is E. Goldstein.